my name is Yasmin Mishlawi and I will be narrating this presentation. This presentation was done by me, Emily Webster, Carla Gomez, and Bpa Presentation. Our topic was on endocrine disrupting chemical BPA and reproductive health. What is BPA? BPA stands for bisphenol A and is an industrial chemical that has been used to make certain plastics and resins since the 1960s. It is a monomer used for synthesizing polycarbonate and epoxy resins. Polycarbonates are used in eyeglass lenses, medical equipment, water bottles, consumer electronics, and etc. Epoxy resins are used in industrial flooring, adhesives, automotive primers, can coatings, etc. BPA has 2 benzene rings, 2 hydroxy groups, and 2 methyl groups. It is manufactured from phenol and acetone, and it is normally in the form of white crystals with a phenolic odor. A man named Thomas Zink reported the first synthesis from phenol and acetone at the University of Marburg in Germany. Zink's work was published in 1905. His paper reported key physical properties of BPA but did not propose an application for its use. Dr. Hermann Schnell of Bayer in Germany, pictured on the right, and Dr. Dan Fox of General Electronic, pictured on the left, developed manufacturing processes for polycarbonates using BPA as the starting material. Commercial production began in the United States in 1957 and in Europe in 1958 when large-scale uses for polycarbonate plastics and epoxy resins were developed. The solubility of BPA. BPA has a low volatility, the ability to evaporate and change rapidly in normal temperatures. Its water solubility is 120 to 300 milligrams per liter. Solubility is greater in alkaline pH, alcohol, and acetones. Where is BPA found? BPA is found in plastic food and beverage containers, composites and sealants in dentistry, lacquers in the lining of aluminum food and beverage cans. The question is, why are people so worried about BPA? Well, it has been shown to increase migration from the plastic, composites, and other storage containers to the outside environment when heated or exposed to acidic or alkaline solutions. It causes polymer degradation of BPA. This will be later explored in further slides. Endocrine disruption. BPA has shown an ability to disrupt endocrine signals in humans. Many endocrine disrupting properties of BPA observed have been attributed to interaction with estrogen receptor alpha. BPA can reduce proliferation of ER-alpha positive breast tumor cells. Studies have found that BPA-exposed cells had enhanced expression of the cancer-promoting protein CMYC. Researchers have also found higher levels of DNA-damaging reactive oxygen species, DNA damage, and greater cell proliferation. Blocking CMYC transcription prevented the effects. Pfeiffer et al. 2015, pictured to the right, showed that treatment with BPA accelerated cell proliferation in comparison to treatment with ethanol. The reason BPA consumption is so important to be informed and aware of is because of the potential harm it can have on the human body. There have been a number of studies where BPA was found or was tested on rats, testing the harms on the endocrine and reproductive system. BPA is known to be one of the most harmful substances on the reproductive system, as well as having the biggest effect of any other bodily system. According to Konieczna, Rutowska, and Rochone, 2015, BPA is metabolized in the liver to form bisphenol A glucuronide. This form is mostly excreted in the urine. Because of its structure, BPA has been found to interact with estrogen receptors as an agonist or antagonist through estrogen receptor-dependent signaling pathways. Due to its agonist and antagonist role, BPA has played a role in the pathogenesis of many endocrine conditions. Such frequent exposure, mainly on a daily basis, increases the awareness of BPA and biomonitoring. These observations include clinical tests of BPA amounts in urine samples, which is one of the best methods to measure exposure. This method of testing also measures the daily intake of BPA and the risk of several endocrine disorders. Some endocrine disorders that were found in males and females were infertility, precocious puberty, and breast and prostate issues. These disorders were reported by the NIH laboratories. Infertility is one of the most common reproductive disorders that is associated with BPA. According to the NIH, increased levels of urinary BPA concentration were correlated with a reduced number of sperm in the ejaculate, as well as reduced motility and viability. Exposure to BPA can decrease the quality of eggs received in vitro fertilization as well. Not only directly, but BPA exposure can affect up to 3 generations of offspring as well. The pathomechanism of the fertility disrupting potential of BPA in women as well as men could be due to its estrogenic activity in the hypothalamus, which in turn disrupts the proper function of the GnRH pulse generator, which impairs the adequate secretion of FSH and LH. The NIH was able to find data from animal experiments that showed that BPA exposure can also be the cause of precocious puberty. Prenatal rat exposure to BPA concentrations accelerated puberty in comparison to the control group. Precocious puberty can lead to other reproductive health issues, and it is not ideal for children to reach adolescence too early in age. Precocious puberty can cause short stature, behavioral problems, early sexual activity, stress, and potential breast cancer later in life. The main mechanism of precocious puberty due to BPA exposure is due to its weak estrogenic activity, which through the positive feedback mechanism stimulate the activity of the GnRH pulse generator, therefore giving the rise in the pituitary LH and FSH secretion. According to the NIH, there are reports on the potential role of BPA in the pathogenesis of breast cancer. Studies in vitro have showed that exposure of the human breast cancer cell line to BPA increased its proliferation and caused increased oxidative stress. High serum BPA concentrations in postmenopausal women were also correlated with the mammographic density of breast tissue. It is also suggested that occupational exposure to BPA increased the incidence of breast exposure. BPA may also be one of the factors that contribute to the development of prostate cancer. Studies showed that men with prostate cancer showed a much higher concentration of BPA in the urine of those patients in the control group. In vitro studies showed that BPA induces the proliferation of the androgen-sensitive human prostate cancer cells. Moreover, exposure to BPA in utero contributed to prostate enlargement of the male offspring. There are many routes of exposure to BPA. Exposure can occur through oral, inhalation, and transdermal routes. There are many items that BPA traces have been discovered in, but according to Konieczna, Rutowska, and Rachon 2015, food products are the major source of BPA exposure. Items that have been known to contain traces of BPA include food packaging, such as food stored in cans and cardboard boxes, dust, dental materials including the materials used in dental fillings, healthcare equipment, thermal paper, toys, and heating of bottles for infants and children. Contamination with BPA may also be caused when food has been kept in polycarbonate plastics, such as reusable containers, polycarbonate water bottles, and drink dispensers. Contamination may also occur in food that has been prepared for eating or drinking, such as infants' bottles when heated and microwaved. Canned foods have been discovered to be the most vital source of nutritional contact to BPA, but researchers have found that meat, milk, eggs, and other fresh produce can contain traces of BPA if their animals were bred in polluted areas or had drank contaminated water. These food products were found to have BPA traces, especially when stored in cardboard boxes. Research has also found that BPA can travel into dust from laminate flooring, adhesive containing epoxy resins, paints, and household electronic equipment. In a recent study, BPA was detected in 95% of 56 dust samples, with the concentrations ranging between 0.8 milligrams to 10 milligrams per gram of dust. Higher concentrations of BPA were spotted in dust from offices and laboratories because they had multiple furniture and electronic devices present. Exposure at home among children may increase because of the amount of items that contain BPA that could be exposed to them when put in their mouths or inhaling contaminated air. Exposure via dust particles was projected to be less than 5% of the total exposure to BPA. Exposure from polluted air is less than 0.4 ng per kilogram body weight per day in adults, whereas in infants is estimated to be 5.3 ng per kilogram of body weight per day. It is evident here that children have higher exposure rates to BPA than adults do. Dental materials are another form of BPA exposure. Dental materials are made up of monomers that may contain BPA, particularly in the form of bis-GMA, which stands for bisphenol A glycidyl methylcrylate. Bis-GMA is often released from dental fillings, sealants, or materials used to rebuild the crown of the tooth. It has been indicated that the highest concentration of BPA was found in the saliva of a patient immediately after a dental filling. The BPA content soon decreased shortly after the procedure. Small amounts of BPA, 0.3 to 0.35 milligrams, can also be discharged from many other medical devices due to its polycarbonate or polysulfone plasticizers. These include contact lenses, probes, inhalers, intravenous cannulas, catheters, neonatal incubators, or even hemodialysis apparatus. The question is, why is BPA used in these materials and what is its use? BPA is used in cans to prevent direct contact of food with metal it's encapsulated in. It ensures that it can resist hot and cold temperatures as well as ensure the durability of the can. Coatings on food storage that are the most commonly used to prevent direct contact with food, heat resistance, and durability are made of epoxy resins. Around 9% of BPA produced every year is used for the production of the lining material found in these cans. The issue with the heating cans during sterilization or food preparation has been found to cause BPA contents to actually leak in the can from the epoxy coating of the wall. This, in result, increases the possibility of BPA exposure from those foods. The highest increase of BPA concentration found in canned foods was found after heating the can at 121 degrees Celsius for 90 minutes. Researchers have found that foods with lower pH and higher fat content contain higher concentrations of BPA, which is another factor in this issue. The EPA regulates many uses of BPA while relying on the FDA for the food packaging uses of BPA. In the fall of 2014, FDA experts from across the agency completed a 4-year review of more than 300 scientific studies. They have not found any information in the evaluated studies to prompt a revision of FDA's safety assessment of BPA in food packaging. To reduce exposure of BPA to sensitive populations, the FDA has banned its use in baby bottles, sippy cups, and infant formula packaging. As part of the BPA action plan, the EPA has proposed the inclusion of BPA in the toxic substances list and identified BPA as a substance that may present an unreasonable risk of injury to the environment. However, this proposed rule has been stalled in the Office of Management and Budget for several years. Many states have taken steps to address the situation by introducing state-level regulations. California, Delaware, Illinois, Maine, Maryland, Massachusetts, New York, Iowa, Minnesota, and Wisconsin have all banned BPA in all baby bottles and sippy cups. California even added BPA into the state's Proposition 65 list. California's Safe Drinking Water and Toxic Environment Act of 1986, which is known as Prop 65. This requires warning before exposing an individual to a carcinogen or reproductive toxin on the Prop 65 list. This law could force manufacturers to use BPA-free linings or explicitly put warning labels on products. Connecticut, D.C., Nevada, Washington, Vermont have all banned BPA in all sports bottles, reusable food and beverage containers, in addition to baby bottles and sippy cups. The controversy of BPA. Over the years, there has been multiple studies performed on the effect of BPA to the human body, as mentioned earlier. The risks of BPA exposure and contamination are still not agreed upon between academic scientists and agency scientists and regulators. There are two reasons for this dispute. The first one is that studies have produced conflicting or inconclusive results. This is mainly due to changes in the endocrine system, which is hard to determine the exact cause. A second reason is that academic scientists and regulators do not seem to agree on which studies are best to change government oversight of chemicals. According to Cornwall 2017, in 2015, the FDA vetted 161 new studies about potential health effects of BPA. The point of this was to come to an agreement between scientists and regulators on the health effects of this compound. These studies included peer-reviewed journals that found significant evidence on the effect even a small amount of BPA can have on the body. At the end, agency scientists did not agree that there was significant enough results to set new policies. Although many states have implemented policies on BPA-contained products, the FDA has yet to implement policies statewide, besides to sensitive populations. People are recommended to follow these guidelines to reduce possible exposure to BPA. The first recommendation is to use BPA-free products. Manufacturers are creating more and more BPA-free products, so when shopping, make sure to look for labels identified as being BPA-free. If a product is not labeled, some of those plastics marked with a recycle code either 3 or 7 may actually be made with BPA. The second recommendation is to reduce can usage. Reduce the use of canned foods due to the lining of the cans having BPA-containing resin. The third recommendation is to avoid heat when food is being stored in cans in plastic containers. The National Institute of Environmental Health Sciences recommends not microwaving polycarbonate plastics or washing them in the dishwasher. This is due to the possibility that the plastic can deteriorate throughout time and eventually leak BPA into those foods. The last recommendation is to use alternative food sources in food containers. Instead of plastics, cans, and cardboard, use glass, porcelain, or stainless steel containers to store hot foods and liquids. These recommendations are very feasible and practical to perform to reduce BPA contamination in food storage. Although some of the modes of contamination can be inevitable, these measures above give the power to those who want to make a change. In conclusion, the FDA needs to continue the review of available studies and information about BPA to ensure that humans are exposed to safe levels. FDA needs to update its assessment of BPA periodically based on results from many studies and introduce regulations as applicable. Additionally, the FDA will also need to continue to consult with other federal agencies, like the National Institute of Health and the National Toxicology Program, the Environmental Protection Agency, the Consumer Product Safety Commission, and the Center for Disease Control and Prevention. On a global scale, FDA continues to participate in discussions with its international regulatory and public health counterparts, who are also engaged in assessing the safety of BPA. Thank you for listening to our presentation.